All right, so we are looking at the top of page 5, and first I'm going to look at the part of the notes here. So when we are graphing on a number line, our first job is to find the critical value, and that's going to be whatever number is involved in that inequality. And then we're going to decide if that critical value has an open or closed circle. So if it's an open circle, it means it cannot be equal to that critical value, which means we're looking at a situation where it's either less than or greater than. If it's a closed circle, then it could be the critical value, which means we end up having that situation with the partial equal signs. We have greater than or equal or less than or equal. And then once we've decided and shaded that circle if needed, then we're going to shade the part of the number line that's going to represent that inequality after you've graphed your critical value. So for an example up here, we're looking at x is greater than or equal to 3. So positive 3 is our critical value. So I would first start off by putting a circle at 3. Now this one's already shaded in because it is a greater than or equal. And then I want everything that's bigger than 3. So the items that are larger than 3 are going to be everything that goes off to the right, because the actual value, we want to have the larger numbers. And you can go ahead and shade the arrow as well, and that tells your reader that that pattern continues on in positive, off to positive infinity. Now another example of this, we might throw in an additional requirement. In this one, we are looking at x is greater than 2 when x is an integer. So for this one, it's a little different. It's just going to be an open circle because it's only greater than. It cannot be equal to 2. But then we are going to have whatever is larger than 2, but is also an integer. So instead of shading everything to the right here, I am going to put dots at every integer value. So this would be 3, 4, 5, 6, and so on. And again, you can use your arrowhead shading that to show that that pattern continues on. You can also use the dot, 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 the ellipsis shows that that pattern will continue on. So any integers that are off here to positive infinity would satisfy this inequality. It would give me a true statement. So if I said 6, okay, 6 greater than 2. Yeah, 6 is greater than 2. So that is an appropriate response for that inequality. All right, let's look at a couple of these. We're not going to look at all of them since you guys are going to have a chance to look at some of these together in class. And then we will look on to adding and subtracting integers. So again, this part we're talking about, making true statements with this. So this is your actual value. Okay, so -1 and 0, which one's bigger? And that's generally what I figure out which one's bigger. And then, back to elementary school, the mouth wants to eat the larger value. And I just plug that in there like that. So -1 is less than 0. We would like to be into less debt. So the -2 is going to be larger than the -5. If you think about that on a number line, you'd have 0, there'd be -2, -5 would be someplace over here. So -2 is farther to the right, so its value is larger than -5. And then between a positive and a negative, of course, we would rather have the positive, so this time the hungry mouth of the fish or the crocodile is going for the 408. All right, we looked at some absolute value ones before. These other ones down here, for looking at which one is greater, you do have to figure out the absolute value of these first, if there is an absolute value involved. So for -12 and -8, I'm just comparing those directly. So -8 would be larger because I'm in less debt. It's farther to the right on my number line. On the next one, this would be 12 once I take the absolute value. This one would be 8. And now I'm comparing, 12 and 8. Well, 12, they're both positive, so 12 is going to be larger than 8, right? I want to win $12 in a lottery. That's better than winning $8. And then we get the same kind of idea happening over here. We've got 256 Or absolute value of negative 256 is also 256. So these two are actually equal. Opposites. So we are looking at the integers and their opposites. So it just means we're going to flip the sign. So instead of positive 31, its opposite will be negative 31. 0 is in its own category, and it is non-negative. So really, 0 itself is just, its opposite is 0. There's not really such a thing as as negative 0. So it's really its own opposite. And then the negative 612, okay, we'll just flip the sign on that and make it positive 612. That would be the opposite. And the key is, with the opposite, is thinking about what number would I add to it that would then get me equal to 0. Because if I add a number and its opposite, I should always end up back at 0. All right. I'm going to skip those right now and look on at page 6. So starting off on page 6. Top of page 6, we are looking at the addition of integers. And we have different rules for whether the signs are positive, or are the same versus different. So if the signs are the same, we add their absolute values. And then we're going to give the answer, which is the sum of those numbers, the sign of the original. So if the numbers are positive, the answer is going to be positive. If the numbers are negative, the answer is negative. So if they are the same sign, that sign continues through the problem and we stay with it. If the signs are different, then we subtract the absolute values. And we're going to give the result the sign of the number with the larger absolute value. And that's why it's important for us to understand the difference between value and absolute value, because right here it's going to determine what the sign is of our answer when we are adding things. The additive inverse property, which I actually just touched on a second ago when we were talking about adding a number and its opposite, that a number and its opposite are going to equal 0. So adding a number to its opposite is going to give me 0. So I have $10 and then I pay $10 to buy something. Now I'm back to 0. I had a positive 10. I lose the $10 out of my pocket, and I end up having $0. And, same thing could happen if I, maybe I pay $10 for a scratch-off lottery card, and I happen to win $10 on that. I am back to a net of 0 that I have spent. All right. Okay, adding numbers with the same sign. This, when they're both positive, hopefully you are remembering this from previous times. We're just going to add them together, right? And it'll just be 15. If they're both negative, my answer is going to be negative, and now I just have to take those two absolute values and add them together. So I'm thinking, okay, what's the absolute value of negative 10? What's the absolute value of negative 6? So that's going to be 10 plus 6, or 16. So a negative 16 is going to be my answer. So I owe $10 and then I borrow another $6. So I go further into debt. I go farther into the left-hand side of my number line. And then the same sort of thing is going to happen here. These parentheses here are just highlighting the fact that there is a negative number there. They are not doing anything else. It's just kind of a little wake up for your eyes. So this one, again, we would add, so 124, those two absolute values, I get 124, but because they are both negative, that's the sign of my answer. When the signs are different, then I have to figure out what the sign is going to be, and then I subtract the absolute values. So for 12 and -7, okay, 12 has the larger absolute value, so my answer is going to be positive. And sometimes I will just write that kind of in my answer blank and then figure out the rest of it. I've made that decision, get that part out of the way. And then I subtract. So 12 minus 7 would be 5. So a positive 5 is the answer for this. We typically do not put the plus sign out there to show that it's positive, but if you want to emphasize that to yourself in homework and things like that, that's fine. Just the software program probably will not like it if you put that in there. And let's see, let's skip to the last, oh, actually, let's go to this one here. So -3 and +9. So again, 9 has a larger absolute value than -3. So this one is also going to be positive because the one with the larger absolute value is going to determine that sign. And then we say 9 minus 3 is going to be 6. So +6 for that answer. The last one is going to be that situation where we end up having 0, right? Because we have a number and its opposite, and that's going to end us up with 0. And let's see here. Now, I am going to skip that last one because we're going to look at one similar to that in class, and I want you guys to have a chance to kind of think about it in class before I go over it. Okay, so we are moving on to the top of page 7, and this is going to be the last page of notes for this first day of week 2. So top of page 7 here. And we are looking at the difference. So another way to talk about difference is that it is the answer to a subtraction problem. And this is a good thing to know. And, you know, that's kind of me hinting that maybe this might be on a test at some point. So know that the answer to a subtraction problem is called a difference. So we actually don't ever end up subtracting. What we do is we change it to adding the opposite. And that is what is shown in the symbols here. So instead of subtracting B, I'm going to add the opposite of B. So change to adding the opposite. And then we can follow the rules for, let's see, that P didn't look like a P. There we go. Then we can follow the rules for addition. So we just have to really remember the rules for addition and rewrite that subtraction as addition. So use the addition rules from the previous section that we were just looking at. So occasionally there will be a couple where you just are rewriting that subtraction problem as addition. So let's look at this first one, 5 minus 11. So I can rewrite that as 5 plus the opposite of 11. And if all you're being asked to do is to rewrite the problem, that's it. You don't actually have to simplify it. That's just it, and you're done. And with this middle one, we would have -11 plus the opposite of -13, which I could simplify a little bit and get -11 plus 13 would be rewritten as an addition problem. And same idea in that last one would happen there. So as you get better at these, you're not necessarily going to have to write out every time rewriting these things as addition problems, but it can be really helpful when we are dealing with a lot of positive and negative signs to do that. So I am going to pause here before we start on looking at a couple of these examples because I'm about to hit the limit of my video.